Hi everyone, I hope the weather's treating you warmly but not sweltering. How is everyone doing? This is Fun Reverse Engineering speaking, and for this video, we'll be taking a quick look at the Rizin framework, a real treasure trove for a reversal of any degree. We'll try to be clear and concise as we go, so clear even your pop will get it. In 2006, Radar project started, created by Pancake. Originally, it was a console-based hexadecimal editor and a tool to work with hard drives. Then the project grew and has grown into a true cross-platform framework to work with file formats such as PE, ELF, Metro. The project got a ton of users and followers. They would even hold conferences about it. Lots of developers started actively contributing to it. But, shall we say, Pancake's conservative views clowned the project development. So in 2020, some of its developers came up with its new fork called Rizin. We are not sure, but it feels like the German name of a certain poison was chosen for a reason or another. Summing up, the project is now independent, open source and supported by an active dev community. It has quickly gained fans among the reverse engineering and cybersec specialists. The project lets you analyze executables with flexibility and comfort. The source code is completely open, as a good cybersec tool should be, and you can get it from GitHub. github.com/rizinorg/rizin/releases. You can be a fearless madlad and make use of the binary builds on there. Or you can be a fearless, intrepid madlad and try building it on your own PC. The choice is yours. Feel free to check out the building instructions at the project page too. It's not easy to cover every capability of Rizin in a short video, so we'll try to highlight the most fun ones. You'll want more instructions, of course, so take a look at the official manual, book.rizin.re. But let us first clarify quite a few important things for the total reversing newbies. Program compilation is a translation of a program to machine code using compiler software. When a compiled program runs, the central processor follows the sequence of the binary instructions, which are its main part. During the machine code execution, the corresponding opcodes and their operands are stored in RAM and make up commands for the OS or the CPU directly. Many compilers allow instead to output the software as assembly instructions. The assembly instructions are the low-level instructions that are a one-to-one match with the machine code the intended CPU understands, defining specific instructions and the data to apply them to. An opcode is the instruction itself, the action to perform. For example, it can load data, perform a specific basic operation on them, store the results, jump to another part of the code. Operands are the parameters of an opcode that may specify the data to process, the ROM/RAM addresses, counters, etc. Next, machine code can be represented as assembly instructions. That's called disassembly, achieved using disassembly software. Reverse engineering is analysis of a target compiled program's assembly to try and understand its logic and workings. You can find out what operations occur in what order, the way the data is processed, and the interactions between the system's components. So that sounds difficult but fun, right? Okay, now let's finally take a look at the commands for Rizin that help analyze the contents of an executable binary file. Rizin, file name. Let's open some executable file. The program console appears, displaying the entry point's virtual address. Question mark. If this command is used, we get a list of all available commands. AAA will start by parsing the entire file for analysis with the 3A letters. PD10. This command shows the disassemble starting from the current virtual address. The parameter specifies how many elements the list will contain. PD-10. However, the same command with a negative value will be showing the disassemble from before that point. AGA will show the dependencies of the build currently loaded in the form of a graph. S address jumps to another virtual address, which you of course specify at the parameter /m searches for the magic sequences in the file. This could be images or retrieve files. /string searches for the specified string. V switches to virtual mode. That looks not unlike your usual graphic interface.
Close your eyes.
Q quiet the analysis or virtual mode. Aside from the main tool, Rizin, the kit has additional tools. Let's take a look at them as well. RZ-ASM-L lists the supported assemblers and disassemblers. RZ-ASM-A x86-B 32 apostrophe add ECX, 21 apostrophe translates to machine code the assembly instructions add ECX 21 for x86 architecture 32-bit. RZ-ASM-A x86-B 32-D apostrophe 83 C101 apostrophe disassembles the machine code 83C101 hex for x86 architecture 32-bit. RZ-bin-I file name displays file info. RZ-bin-H file name displays the header entries. RZ-bin-S file name displays all sections. RZ-bin-S file name displays symbols. RZ-bin-ZZZ file name displays detected text strings. RZ-hash-L lists all available hash algorithms. RZ-hash-A sh1-s quote test string quote outputs the sha1 hash of test string. RZ-diff-t bytes file name 1, file name 2, byte-wise comparison of two files. RZ-diff-t lines file name 1, file name 2, line-wise comparison of two text files. Rizin commands are very convenient for writing various scripts. Our favorite: count the opcode frequency in an executable. Then unreadable constructions follows. Certainly, pure console is not for everyone, which is why there is a piece of software called Cutter, which has GUI. Sadly, at the moment we made the video, it doesn't support everything Rizin has to offer. You can download it from good old GitHub too. github.com/rizinorg/cutter/releases. Well, that's all for now, and thank you for watching. We tried to make this content as accessible and clear as possible. How was it? Give a like if you pop nuts. We'll leave the links to Rizin and our GitHub in the pinned comment.